Okay guys, picking up, this is the second video describing transformations of each function compared to the parent function, and I'm going to be taking off this extra part where you need to graph. If you were here with us last quarter, then we did spend some time talking about this. We did have a b, but we're not going to worry about that here, so let me just put this form out here. Alright, and let's talk about each part. Your h is your x-coordinate of your vertex, but we're not even going to think about it in that way. We're going to think about it as your translation. So remember that these two things give you translations. Remember, translation is a fancy way to say shift, okay? Move to the left 5 units or move down 4, okay? Just remember, so, and then more specifically, I'll add on. This moves it left or right. Remember, though, it kind of does the opposite because of that negative sign, which we talked about in the second video. And the one over here on the right, k, that moves it up or down, okay? And that one's not the opposite. So if it says plus 8, it actually moves the whole graph up 8. All right, now let's talk about a. You can actually pull a lot of information from your a. We already talked about that if it's positive, it opens up, and if it's negative, it opens downwards. But this a right here gives you a vertical stretch or shrink, all right? So I'm going to include that as well in pink. Gives you a vertical stretch or shrink, okay? If the number is bigger than 1, it will stretch. So let me just memo that in here. If a is bigger than 1, or I should say actually the absolute value of a is bigger than 1, then it will stretch. And if the absolute value of a is less than 1, then it will shrink, okay? So kind of think about that. The reason why we say absolute value is because I don't want you to think that negative means it's going to shrink. Actually, negative means the whole graph will point down. But I really care about this specific number. Is it bigger than 1? For example, 2. If I was going to multiply something by 2, I think it makes sense that something will get bigger. And if you multiplied it by 1/2, then it's going to get smaller. All right, so we did talk about horizontal stretches and shrinks and reflections last quarter when we spent a lot of time on transformations, but we're not going to worry about that here. Over here, we would kind of say, here, there's no reflection, or at least no vertical reflection, and then specifically about the about the x-axis. The second one, however, that would be a vertical reflection about the x-axis. Okay, so we're going to look for all of those things. We're checking for the sign. Is absolute value of a positive or negative? Does this move left or right? And then does this make it move up or down? Okay. So looking at the first one, I think these are different examples than you guys had on your review. Let's see. Yeah, this one definitely is. So looking at a few things, I have a 1/3. I've got this 4, and it looks like a -4, and then I've got +3. So this, I've got a few things going on. Because this is a positive, there is no vertical reflection, okay? Because that's 1/3, my a is equal to 1/3. That's going to give me a vertical shrink. And what is it dividing it by? It's dividing it technically by 3. So you could say vertical shrink, factor of 1/3, or you could say vertical shrink by 3. For Algebra 1, you don't have to worry about it being anything on the top as far as your numerator being anything different than 1. So this will be vertical shrink by 3. Let's look at these two things then. Okay, this is my h, that's my k. Good practice to think about that. This h is actually positive 4, opposite of what it looks like. This k, it looks like 3, it is actually 3. Okay, so this one, h equals 4, it's going to move it to the right, 4, and then k being 3 is going to move it up 3. All right, so give your chance if you'd like to pause the video here to try number 2, but I'm just going to move on. Okay, here I notice actually 4 specific things. There is a negative sign. My a is not equal to 1, and I do see a number besides that. I've got a 1, it looks like a +1, and then I've got a -5. So each one of those things, this one gives me a vertical reflection over the x-axis. This one here is a vertical stretch by 2. This one looks like +1, but really h is -1. That's going to have my graph move left 1. And then -5, my k is actually -5. It's going to move it down 5. Again, I know I'm writing very sloppily. Hopefully you're listening as you watch this anyways, so you can kind of understand if you don't understand, or you can hear if you can't understand my writing. All right, so let's write these things out. I'm going to just go left to right. Technically, that's not the order that we would list these things in. But as long as you give me all of them, I will give you full points. Okay, so first thing, I've got a vertical reflection over the x-axis. I've got a vertical stretch by 2, and then I'm moving left 1 and down 5. Okay, so as a reference, the parent function is what we're really comparing it to. So all of these things, every single point that would have been true for this one here, they all get multiplied by 2 as far as the y value. They're flipped on the other side of the axis, and then they move left 1 and then down 5. Let's talk about number 3 through 6. Show, and with work, whether the function is even, odd, or neither. Okay, you can go through your text or through the videos. Even, odd, or neither really, its significance kind of tells you what kind of symmetry it might have. The steps are, let me silence my phone. Plug -x into your function. And that's for your x's. Okay, that's your first thing, all right? And then we're going to compare. Compare with the original. And then there's a little bit more. I'll kind of show you because I don't quite have the room there. All right, I'm not going to do 3 through 6. I will do these examples here. So what I mean is I'm going to take this original function. Instead of f of x, I want to do f of -x. Okay, so let's plug that in. F times -x. I want to get rid of the parentheses. So I'm going to consider, is 5 times -x, can I simplify that without the negative? And I can't. It's going to give me a -5x. Now we'll get to the comparing part. Because up above we said we're going to compare with the original function. In this case, the original function is this one right here. More specifically, I'm comparing it to 5x and this -5x. If they happen to be the same thing, and then I know this is not a great example, maybe it's hard to tell that they're not the same, but hopefully you can tell one's positive 5x, one's negative. In this case, it's not going to be the first thing we're checking, which is that it's even. All right. The next tool or the next step that we check is to see, is it an odd function? Okay. And the way that you check if it's an odd function, we're going to use some of our factoring skills that we picked up from last chapter and factor out a -1. So if I factor out a -1, in parentheses, I'm going to rewrite what's left over. I know I've only got one thing here, so it looks funky sometimes, but it is a positive 5x. Now I'm comparing again with my original function, but only the stuff inside of the parentheses after I factored out the -1. Now, does this look like my original function? If it does, then there is some type of symmetry going on, and it's specifically an odd function. So since this one does, it is an odd function. Now, if you did both of these steps and the stuff inside didn't match up with the original function, then the only thing left would be neither. Okay. Let's check out some of the other ones. So f of x is equal to -4x squared. We will plug in -x. -4 in parentheses, I'm going to get a -x to the second power. Now we're going to get rid of that parentheses. Guys, if you don't know, anything to an even power, and in this case 2 is even, and that's a power, anything to an even power will make the product positive. Okay, so if you did -x times -x, which is what -x to the second power means, you take the same thing, multiply it by itself twice, you would get a positive x squared, and that's what I would like to write. So this part right here becomes a positive x squared. The -4 stays the same. At this part, we're going to compare with what we've got with what we started with. Is it the same? And in this case, it is the same. Therefore, this is an even function. I don't need to do anything else because it's even. Let's check out number 3. All right, same deal. Plug in -x, 1/2 times -x to the second power. In this case, this is another scenario where the negative goes away. I can just rewrite it as 1/2 x squared. This is the same as this. Therefore, it's an even function. Okay, check out number 4. We are going to evaluate the function by plugging -x into it. All right, everywhere I've got an x, switch it with a -x. All right, the +1 doesn't have an x at all, so that just looks the same. All right, now here is another case where this one will turn positive. The -3 is still there though, and I get a -3x squared. So far I'm kind of like it's looking good. If I look at the next one though, +2 times -x, when I get rid of the parentheses, this actually turns into a -x. That's not going to match up, okay? The +1 of course will match because I didn't change it, but if I compare now, maybe I can make this bigger. If I compare this with this original function, because of the 2x's not matching up with their signs, this is not even. All right, so the only other thing to check is to factor out a -1. That would make this a positive 3x squared, this a positive 2x, but this a -1. But if you compare now the stuff inside of this parentheses with this, although now the 2x's are both positive, everything else is wrong. So it's not, it's not odd, therefore it is neither. Okay? All right, I'm going to stop this one here.